Yesterday we ended off with the homework. I saw 2% did the homework and no one else. So I guess they probably didn't have enough time to do it or whatever. But the 2% who did it got it correct. They got it correct. I was surprised to see it. So if that's you, you did a good job. So we're gonna do it in class to just so you could see how we walk through these problems. This is a simultaneous equation. It's equation whereby we have two. It's a system whereby we have two equations. One equation, this one equation right there, this is the other equation, and we have to solve them both at the same time, right? And so let's do it. So I like the method that one person chose. It was the best method for this, and I was glad that they chose that method. You can do simultaneous equation either by elimination or substitution. But the way how this question is set up, to do anything but substitution is going to take you longer. And so, I mean, sorry, to do anything but elimination is going to take you longer. So I'm glad that the person chose to do elimination. That's the perfect one for this. So you're going to solve the simultaneous equation by elimination. All right, and so this is how it works. What we do is we have, and you know, the way how we know it's elimination is perfect here, because we have a plus and we have a minus. That like obvious, like wow, like that's exactly what we gotta do. So that tells us right there, elimination easily. And also elimination, you know, when all the variables are lined up together, so we have A and A, B and B, and the constants are lined up together properly, that shouts loud and clear, elimination, elimination. And so we're gonna use elimination for this. So with elimination, you want to draw a line, right? You're gonna do some tallying. So basically what's happening is you wanna add these two equations. That's basically the idea. You wanna add these two equations. And so if we add in these two equations, we add them variable by variable. And we ask the question, what is A plus A?
That would be 2A.
2A, very good. 2A. So that's the first thing. That's sorry, let me put this on the side so you can see what's happening. So the first thing we add is the A's, so it's gonna be A plus A, which gives us 2A. Okay. And so just like how we do regular addition, we do column by column, the same thing we're gonna do with here. So we're gonna already finish the first column, and we're gonna do the next one. What is plus B minus B?
0.
So we have positive B minus B. That gives us what?
0.
0. B, which is still equal to 0. All right, so here we are left with positive 0. So we basically cancel out these two terms. One is positive, one is negative. We cancel them out. And so now we are left with, this is equal to, what is 59 plus 17?
Hold on, I don't have my calculator. Okay, 9 minus 7 is 2. Minus 1 is 4. 40, 42, I think.
76.
76?
Oh, we adding or we minusing? Oh, shoot, we adding. Sorry, we're adding. My apologies.
No problem. We forgive you. We know you don't have your calculator right now.
My calculator isn't here. I'm
Boy,
sorry.
if Cooper was there, she would have laughed ahead. All right.
Mom, it's a pity. Don't remind us.
I know, right? I know, right? I had to, man. So, Cooper, we miss you already.
Okay, I got it. Okay, we're back.
All right.
Okay, 59 plus, right? 17. Oh, yeah, 67. I mean, 76. So, that makes sense.
All right. Okay, so what is 2A plus 0?
2A.
2A.
Yeah. That'll be equal to 76. All right. And what we're going to do at this juncture?
Divide by 2.
Divide by 2. Divide both sides by 2. Very good. So we divide both sides by 2 to get rid of this 2 here. And so these 2 cancels. Right? And so we are left with A is equal to, what is
30,
76 divided by 2?
38,
76 divided by 2 is
38.
38. Alright? Good stuff. And so that's what A is. A is equal to 38. Okay. Now remember that we already know what A is, so now the question is, what is B? Alright? What is B?
You'd have to grab one of the equations from the beginning.
Yeah.
It could be A plus B, or it could be A minus B.
Very good.
And then wherever you see A, you would put the number you just solved in the slot to represent A, and then you solve it to get B.
Very good. Very good. Alright, so we're gonna use, so we have two equations. We have equation 1.
So you're doing like a substitution then?
Yeah, we're gonna do a substitution, yeah. So we have equation 1 and we have equation 2. Right? We could use any one of these to do substitution. Right? But I'm just gonna choose equation 1. So using equation 1, we know that based on equation 1, we know that A minus B, sorry, A plus B rather, is equal to 59. All right. We know what A is. What is A?
38.
38 plus
B
is equal to what?
59.
59. And we send the 38 over. And we are left that B is equal to
21.
59
No.
minus 38. And so therefore B is equal to
21.
oh my goodness. I hate when this happens. B is equal to 59 minus 38, which is
21.
21. So the value of A and B that solves this equation, so the answer, right, is going to be that A must be equal to 38 and B must be equal to 21. All right, and kudos to those persons who got it. Very good. Very good job.
Mr. T, you could explain when we are to do elimination and substitution again, please?
So it's up with elimination. You know it's elimination because the variables will be lined up together. So A and A, B and B, constants and constants, right? That's elimination directly, all right? For substitution, it's gonna be, it's gonna look weird. So it's gonna look something like, give me one moment, I'm gonna come back to that. It's gonna look something like, if we add like A plus B equals to 4, right? And then we have that, say A is equal to 14, let's say use 18 plus B. You see that? Notice that. There's a difference, right? The variables are not lined up in order. So this is a B and this is a A. Yeah, this is a number and this is a number, but you know, there's no corresponding B on top. So they are not, you know, in the right place. So this one is a cry aloud substitution, easily. Because they already tell you what A is. They substitute that in for B. And then that's how you would do it. We wouldn't use elimination for this one because it just require more steps, because then we'll have to send over the B and then we have to do elimination. But this is ripe for substitution. So that's how you know the difference. Elimination, you know, The variables are lined up together, constants are lined up together. Good. Substitution, it's weird looking. It's not properly arranged. All right, that's that out.
Thank you.
Okay, no problem. Someone's asking to join. Thank you, Miss Penniman, for sending in the notes. All right, anyone else?
Actually, I don't quite understand how you did this elimination, you know.
You don't?
No, because it don't make sense to me.
Go ahead. What part don't make
You
sense?
say A plus A.
It's 2A.
How could you do A plus A?
Why not? What hindered me from doing
Because it's A plus B and A minus B.
that? Okay. Oh wow! I'm not laughing at you, Mr. Bethel.
No, that's how I see it. Like,
No,
I
I'm
would
not
just
laughing at you. I honestly, someone sent me a message, and I'm like, what a weird question.
okay. There I mean.
That I you. Okay, so yeah, what we doing? We adding the equations. That's possible. You can add the equation. So we
So
adding.
you putting them in a bracket or something?
No, I'm saying that this equation is added to this equation. That's what I'm saying. That's how we eliminate them. All right. To get a resultant equation 3. All right.
But then you minus what?
Okay, so when you say we minus, all we did was we added like variables. So something we could do. You understand?
So A plus A, B plus B.
Yeah, and then constants.
But you take away B.
Because look, this is okay. I see what you're saying. I see what you're saying now. This is B, right? Plus negative B. That's what we did.
Okay.
So it still end up with B minus B, which is 0. Okay. And then
So you're doing it like a vertical way, right?
Yeah, vertical column by column. Yeah.
Okay.
Yeah. That's just the algorithm that gives us the answer. That's it. Follow this way and you always get the answer. That's it. So it's not like a magic to it, you know. All right. Okay. All right. So that's it. Any other questions before I move on? Any other question? Are we good?
Hi, good.
Same. So
I guess with Mark.
I guess that's the only one who ain't do the homework.
Look like. I know Nancy did it. She got it right. Alicia did it. She got it right. So the only 2. Okay. All right. So I think we're good. Okay. So regular polygon below. All right. Let's tackle this question. All right. All right. So this one says that the polygon below represents a regular octagon. What do we mean by octagon? We know.
A shape with 8 sides.
Shape with 8 sides. Yeah. closed figure. First of all, polygon means, polygon, that's a closed figure, right? So it has, so we have one point and then it actually closes, it's not open, right? And it's 2D, all right? So we have this polygon here, closed and 2D, and that's 8 sides. So 1, 2, 3, 4, 5, 6, 7, 8. Now they use a very important word here, right? To describe this polygon, they say it's regular. Okay. So when we deal with a regular octagon, it's very important that we understand that with regular polygons. So regular polygons. I spelled regular wrong. Look at that. With regular polygons, we know that all sides are equal and all angles are equal, right? For example, like we have the square. That's a regular. That's the cute name that we give the regular four-sided polygon. I mean, regular four-sided, yeah, polygon is a square. For a three-sided one, for three-sided. So if a thing is a regular three-sided figure, we call it a. If it's a regular three-sided figure, what do we call it? Regular three-sided. Everybody's quiet.
A regular three-sided figure?
Yes, ma'am.
That's not a triangle.
Close. Very close. Are all triangles, do all triangles have all equal sides? And do all triangles have all sides are equal?
Oh, you mean a type of triangle?
Yeah.
That's scalene?
No, it can't be scaling.
Oh, I can't remember.
I can't remember now what it is.
Oh boy.
Can you repeat the question?
I want a regular three-sided polygon.
Why it's so hard to remember? We just look at it.
Again, this is elementary stuff. Boy, if Miss Cooper was there, we're gonna be stuck here. Should ring that off. I guess Kennedy took
Really?
the day too. Even Lionel took the day off. Oh, okay. All right. What they call it, the three musketeers. They probably going on a date. All right. Yeah, it's equilateral triangle.
Oh.
This is the regular.
I did not remember that.
Three-sided figure. Alright, and for the five-sided figure, so for regular five-sided polygon, what do we call that? We call it simply a regular pentagon. Now it's important to note that with these shapes, all sides are equal if they are regular now. All their sides are equal and all their angles are equal. So let's do a little kind of example type thing. So so with our triangle, remember all sides are equal, all angles are equal. So if this is the equilateral triangle, assume that it is, all its sides are gonna be equal, right? And all its angles is gonna be equal to what number?
You mean in a triangle?
In a triangle. What does all the angles in equilateral triangle equal to?
180.
No, I don't.
60?
60, very good. So each of them must be equal to
Oh.
60 degrees because all of them must be equal. So you basically have to take 360 and divide it by
Divided by
the
3.
number of sides that you have, right? Just 3, and that gives you 60. So all of them should give us what? 60 degrees. Right? That's an equilateral triangle, and that's a regular triangle. Formula of that. Regular. And notice how we get the interior angle of a regular polygon. We just take 360 and divide it by 3. So if we do that to get the equilateral triangle, what is going to be the interior angle of a square? How are we going to figure that out? Remember, all of them must be equal to each other. So how are we going to figure that out? The interior angle of this regular polygon.
Divided by 4.
Divided by 4. Very good. You know they call that? What you did there, they call that? Oh my goodness, it's been a while, eh? Oh, boy, I used to know it out of my head. Anyway, it's an extension
I
of.
also know this for like Bgcse or Bgcse. Are you supposed to know this for the Bgcse?
This is your Bgcse paper.
Oh, would you?
Bgcse paper. I mean, what you want me to do?
No, I'm just asking. Sorry.
Yeah. The first question: is it relevant? Of course, it's relevant.
Nah, see, he's trying to be as efficient as possible.
Of course. You realize that when you take the Bgcse, everything in Bgcse is fair game, you know. Fair game, buddy. They could throw a heptagon on your.
No, I just was amazed because I passed it, but I didn't learn this. I didn't figure out how I passed it if I learned half of the stuff.
You got lucky. They ain't trying to run your exam. Alright. So 360 degrees divided by 4 is what? One of these days remind
90.
One of these days remind me to show you all the syllabus, okay? Like the curriculum.
90.
And to see how much things God is be saving y'all from when y'all take your exams. 90, so it's gonna be 90 for each. Alright. And so this is the formula for the regular four-sided polygons. Alright. Now if we wanna go by extension for the pentagon, right? Pentagon. The five-sided shape. When you think about pentagon, this is 1, 2, 3, 4, 5, 6. Too much size. 1, 2. Oh, these are rectangles. Okay, let me get a pentagon from online. Regular pentagon. Regular pentagon. So good. So all the sides are equal and all the angles are going to be equal. What are all the angles are going to be equal to?
72 degrees.
72 degrees, very good. Good. So, Mr. Floyd Bethel, I'm proud of you, you know.
Too early to be proud.
No, I
gotta be proud after a pass.
No, I see that because you made it to all days of class. Usually you use by Wednesday. By Wednesday.
Yeah, today was, we have a long weekend, so I say,
Okay, all right.
What the heck, you know?
Okay,
Let's
all
see
right.
how it play.
Exactly. Okay, because I know by Wednesday you stop out, take the midweek break, and then maybe we see you on Thursday. Maybe.
Yeah, that's because I don't want to overload myself, you know.
All right.
In the morning, I was trying to working hard, dealing with customers.
Uh-huh.
I'm trying to learn physics, you know, at the same time. So it's getting frustrating, you know. Every
Oh,
second you got to put down the book, then you forget what you just learned, and you get do it over. You're doing it over to get to deal with the customer, and then
but you can't get mad at the customer.
no, I don't get about the customer, but I just saying like it's just a frustrating thing to deal with.
Yeah.
And then I go to
They
all
ain't,
the
they ain't know
chemistry
you
and
want to
then the
learn
same
physics.
thing.
They ain't know you want to learn physics. That's why you hard at them.
Yeah, and then there's one talk to your fair away. It's like
Yeah.
I
That's it.
entertain them now.
Yeah.
Because you know I'll entertain any conversation will come my way. So
Boy, you know that.
but sometimes there's one talk for like 20 minutes straight.
Wow.
So, like that time all they need to do is go out the door, you know. That's all they waiting on. They just literally walk to the door, have it halfway open and talk for like 20 minutes, letting people out and still talking this way.
Typical behavior.
Oh boy.
Typical behavior. Typical. 360.
You can't hate it though, because some
Yeah.
people that might be what they just need, you know, just to
Yeah.
live another day.
Yeah. Real.
Never know.
No, you never know for real. It's correct.
I could be saving someone's life doing that.
That's true. That's true. You never know. All right. So to get the interior angle of this pentagon, we divide by 5. Why do we divide by 5?
Because it has 5 sides.
Because it has 5 sides. Okay.
Yes, that's 5.
Yeah. Certainly. And so that's the thing about regular polygons. And I'm gonna give you the formula right now. Right when we finish with this slide.
Don't move it.
Don't move it. Okay. So there's a general formula. The formula for the interior angle of a polygon is going to be the formula for interior angle of a polygon is going to be equal to
Give us that before I think.
divided by the number of sides. Did I? I think I did it in general.
I think it's n times 180 divided by 360, right?
No, not that one. Not that one. N times 180 divided by 360. N times 180. No, not that one. Okay, so.
Hold on.
Okay, so.
Mr. Buti, while you're at it, could you be able to tell me the difference between the one he just said to the one you're about to show us?
Okay, so.
I tend to get confused.
The difference is, one is when you're trying to figure out, so this one, we trying to figure what the interior angle is, right? We don't know what the interior angle is, so trying to figure what it is. And in this case, we know the number of sides, right? So we know that. And we are trying to find the angle, right? So in this case, we know the number of sides, and we're trying to figure out the angle. The other one is the opposite way around. So you know the interior angle, you're trying to figure out the number of sides. See the difference? So that's the case. So say for example, I say if you know that the interior angle is 90, how much sides should the polygon have?
4.
Well,
4, right? 4. The regular polygon should have 4. If you know the interior angle is 72, how much sides should it have?
5.
5. Now, what if you know the interior angle is, say, let's say if it's 32, how much number of sides? Wow.
32.
Yeah, that's where that formula comes into play. You see what I'm saying? And you'd have to use that formula to figure out the number of sides. Okay. Now, 32 is just a number I just say out, right? I'm just giving you an example. All right. So interior angle of regular polygon formula. formula. All right, exterior. Okay. For a regular polygon, the size of each interior angle n minus 2. That's the formula they give? Okay. Okay. I thought it's going to give a more straightforward formula. Let me see. Oh, we did it wrong. It's not 360 divided by the number of sides. It is this one. Yeah, n minus 2 times 1 to the over n. Now the other one, I thought you was referring to the other one that we did when we was trying to figure out when we was trying to figure out the number of sides. So it is this one. Okay, so it's not 72. That's strange. Okay, we did that. I thought it naturally followed. Okay, so it is actually, so let me just verify. Angle and interior angle of regular polygon, regular pentagon. $108. Okay, so we was wrong. My apologies for that. This is wrong. If we extending it, we have to use this formula. So it's gonna be n minus 2 multiplied by 180 divided by n. Now here n is equal to the number of sides that we have. So n is what? 5. That's just gonna be what? 5 minus 2 multiplied by 180 over 5. This is going to be equal to what? 5 minus 2 is what? 3
3.
multiplied by 180 divided by 5.
40.
We have 40? Yeah, you have 40.
I said 540.
Oh, you mean for
Wait, you
the
divide it.
You divided by 5. Yeah.
Oh shoot, sorry.
So 3 open bracket, 180,
3 times 180.
540
540 divided by
divided
5
by 5.
is 108.
Yeah, 108.
I was trying to do head math, sorry. It took a while.
Alright, so my apologies. Each side and here supposed, each angle rather, and there is 108. Because that would be right. It does increase. It wouldn't just be 360. That's true. And how in the world I get 360 divided by 3 is that's so dumb. It's 10 it's 108 it's 180. Anyway, let me change it. I don't know how I got that. That's so dumb. Okay. I was thinking 360. No, this is wrong. It is, boy, I hope if someone watched the recording, they watch it all the way to the end. Else they'll think I teaching you all foolishness. Okay, so this is 180 divided by 3. That's what it gives us the 60. And then it's 360 divided by the 4 that gives us the 90. And the 540 divided by the 5 it gives us the 108. So my apologies there. So 108. And 108. Good. So all this supposed
So to be clear, so anything above 4 sides is that's when you use this formula.
No, this formula works for the other ones too. So for example, if we add 3 minus 2, that's 1, right? So it's going to be 180 divided by 3, which is 60. And if we add 4 sides, it's going to be 4 minus 2. 4 minus 2 is 2, and 2 times 180 is 360. And the number of sides is going to be 4, so it's going to be 360 divided by 4. See that?
So I could use our formula when I'm trying to figure out
the interior angle of any regular polygon. And so the reason why
regardless of the amount of sides, right?
Regardless of the amount of sides. And that's why
you could go back 1 minute, just one, please. Thank you.
So with that in mind, let's figure out the interior angle of that octagon.
Okay, you can move it.
Yeah, so with that in mind, that formula in mind, let's figure out the interior angle of this octagon. So that's angle F, right? How do we figure what is angle F? All these supposed to be the same size. So each of them supposed to be the same size. And so, because it's why must all of them be the same size?
Because it's a regular octagon.
Yes, it's a regular polygon. So what must each of them be? What must they all be? Try it on your own. Calculate.
Okay.
What you get?
N equals.
I'm sorry, is this where we use the formula?
Yeah, certainly.
Okay.
We're trying to find the interior angles of this octagon. Someone's asking to join.
I get 135, but I could be wrong.
135?
Yeah, I think it's wrong though.
I get 135. I know it right.
Why you know it right?
Because I stick to the formula.
Exactly.
I'm confident because I freehand. I'm confident.
Say it again, Mr. Bethel. Like, I don't
But
understand.
if it ain't, I know I right because maths. I stick to the maths formula.
That's it. Stick to the formula. You don't gotta be doubting. Oh, I know it right. And it's so right that even if I tell you differently, you could say, Mr. Petit, you wrong.
Exactly.
That's all right.
Mr. Petit, you don't notice something today? They different.
Why?
Time moving so slow.
Slow? No, man. It's almost 7 o'clock. I don't know what happened.
Man, when Cooper's BS already be 7:20.
You rolling, boy. What? Cooper don't give us a break, boy. She rolling. Listen. She's a good student, man. So we can use this formula. Let me
I got 135. Yes, I'm a lot slower than everybody, but I got it.
not an 8. No shame in this game. Got it.
Slow and steady wins the race.
Hey, listen. So wait. This is no man. How come Kennedy come? Then after a few minutes, then Lionel come. Oh boy. This relationship, boy, I know.
What are you trying to say?
I guess came home.
No.
Yeah.
I guess came home.
Y'all, Kennedy just reached his high class. Then, interestingly enough, Lionel pops in. Boy. Oh boy. Sound fishy to me.
You ain't gonna let this go on.
Now you see how Nancy is feel? Nancy,
Man, I don't want to be involved. You just drag me into it. What is up with you and me? What is up? Did I offend you?
no, man. You in good terms. I went Lionel and Kennedy case, man.
But you had to drive. Don't include me.
Don't include you in it.
No.
Oh boy, she don't want to be included. Okay. So it's just you and Lionel, just Kennedy and Lionel. They gotta fight this fight. So here N is what? N is 1,
8,
2, 3, 4, 5, 6, 7, and 8. So N is always the number of sides.
Side.
So it's gonna be 8 minus 2 times 180. All divided by N, which is what? Still 8.
8. Oh shoot! So that's why I keep squatching over there.
And what is 8 minus 2?
6.
6.
Very good. 6. Remember after 180.
So we need to
8. And what is 6 times 180?
1080.
1080?
1080.
1080.
I'm a little confident in that answer.
Divided by 8.
Yeah, I use calculator, so trying to not use calculator so much.
Listen, Nancy, don't mind them. Like exam, check 2 times 2 on your calculator. Check everything.
I do, but I just, I don't want to be so reliant on.
Better be relying on that calculator next time.
No, I know, but for now, I want to, work the brain a bit.
Okay, that's no problem.
Yeah, so your students could say off my case, I'm working a bit.
Not me. I even want to know what this is 2 times 2. I just said it the calculator.
Exactly. 2 plus 2. What is 2 plus 2? I ain't thinking about nothing, boy.
Yeah.
Put everything in my calculator. No second guessing. Oh, I thought 6 times 3 was 70. No, sorry, I thought 7 times 9 was 72. Oh, you thought it. Go on the back of the book, you realize that 7 times 9 is 72. Alright, so be careful. So it is 135, so angle X is equal to
135 degrees.
So what is Y?
Y would be 135 divided by 5 divided by 2. Sorry, Miss Reckley, you could go.
No, you have a different answer. You might be right, so no, you go.
You so confident in my...
Here we go again. I going with my 135 times. divided by 2. I hear someone say that. Going with it.
Miss Rackley, you might be right. You might have choked potential there.
No. I think you're right. No.
Oh my goodness.
I use no calculator, you know.
I'm thinking now what how y would be, because we know that.
I think the reason I did it that way is because if you look at it, it's splitting it in a half, and like how you have this thing bent over it. I figured that would be like I thinking about it like a point, if you understand what I mean.
How do you know that's a half of it?
Because
yeah,
it's like
just looking at that.
Yeah, it's just like the line itself is okay. If you extend the line where the one next to y, it gives reason, if you understand.
I'm saying.
Do we have to put a tractor on that?
It said not drawing the scale.
Is that what you call it? Co-interior. That's why I say 135. It's wrong, but because of the co-interior angle.
Co-interior angles. That idea wouldn't work out.
So we wrong with our answer?
I'm thinking now. I'm thinking how I would get y.
Because it's 1 point, so I figured you just divided by 2 because you're trying to find 2 of this.
I understand, but why? Who tells you that that's half of it?
Because it's the way it's cut.
It could be 3/4. No.
I'm saying, like, how do we know for sure it's half?
Well, this is what I get for not using.
I can't tell you how.
But Mr. Petit, if you cut this, if you do this symmetrical, wouldn't that be half?
We have to look at it in some geometrical property that we missing.
But if you 1, 2, 3, 4, we have 4 sides on the top, 4 sides of the bottom, and it cut of the line of symmetry, so that gotta be half.
Cut of the line of symmetry.
Yeah.
Line of symmetry.
Because I was looking at it right, as 180, if you understand what I mean, right? Because if the lines joint at the point where 2 and 3 is, we know that would be 108, right? And then of y would obviously be, I was thinking like, because it's 108 here, and then this would, because it's like a triangle automatically equal to 180. So I figured y minus 108 would give us that. I mean, will give us y, and then the same thing would apply to z.
That's my thing. If y is 135 divided by 2, then how do you get z?
Z is worth 2 points.
It's worth 2 points. But if you're making the case that this is half, equally half, then why this is not equally half?
Because wouldn't we?
Yeah, because it's not in the line of symmetry. Okay.
That'd be like 1/3.
Yeah. So wouldn't it be like when you already find, because you already know what this is, 135 here, where 2 and 3 is, when you get the answer for the inside, automatically when you add them and minus it from where to get the inner part of z, and then you minus that from
how you get the
area.
That's the question. How we get the inner part of this?
When you minus 135 divided by 2, and then you put it in here, and then you add it to the full angle where 2 and 3 is. I think you should put a letter there so I wouldn't get confused. And then you would add them and minus it from, I think, in 180, and then you'll automatically get the inside of z.
That's the thing. The inside of z is important. If we could somehow get that, that's what's stopping us.
That's my first suggestion. I was given away, but you can tell me if I read it wrong. I don't know.
We can make the case that this is half. I think we can make a strong case. I think, for me personally, let's see if we could draw it actually. So, geo, I not GeoAlgebra, one moment. I'm trying to remember the name of the site where they allow you to draw it.
No one else got it, Mr. Petit? Like,
I'm thinking that. Okay, let's see. Is it GeoAlgebra? Let me see. Yeah, GeoAlgebra. Yeah, that is it. Okay. Alright, so we do have one.
And I'm not YouTuber have a video on this.
On what?
On this same question.
Who YouTuber?
Bgcse Math Paper 2.
2019.
The same question, yeah. I passed, boy.
I passed, boy.
Yeah, you do the same thing.
Okay, let me check that. Let me share the screen. I think we can make the case for y by dividing it by 2. The only one that I don't know is how in the world we can get z. That I'm not sure. Where are we? Y'all can see my screen, right?
Yes, sir.
You sure?
Okay, so we're trying to figure out how we get z. I don't know, honestly. Thinking about it, we know that this is 1, 2, 3, 4. That's a pentagon. I mean, that's a quadrilateral. No, this is half of it for sure. Hitting the flat surface.
I'm becoming confident in my answer. I think when we get y, the inside of y, and we add those two together minus it from the area where z is, automatically, I think we'll get. You don't think so?
I don't think so. I don't think so. I don't think so. Paper 2. Oh, he did it. Okay, he did it. He did exactly that. Let's see. Make sides. 135, we got that. Divide both sides by. Okay, yeah. What? Okay, so we divide both sides by 2. That's correct. We could live with that. Then how we got that? Okay. Pentagon. Okay, that's Z. Sorry. And then it shows. Oh boy, perfect timing. One moment. It's blurry on my side. My goodness. Yeah. Okay. Okay. Hello?
Welcome, ma.
Yeah. Y'all can see my screen?
No, sir.
No,
Any
sir.
share anymore?
No, professor.
Okay. Okay, so he take it as he use the idea of a quadrilateral. So we see how we said that that's a quadrilateral. We know angles in a quadrilateral must equal to 360. Yeah, that makes so much sense, eh? Wow. So this is, we know what this is 135, 135 for sure. And he's making the case that both of them is Z. Why? Why must both of them be Z? Let's see.
Corresponding? No.
I don't know. I don't know why you would say both of them is Z. Let me let's read the subtitles. Yeah, we know it's 135. That's for sure. We know D is 135, like he's saying. And if these two angles are equal in this trapezoid, okay, okay, all right, okay, I see. All right, so it's an isosceles trapezoid. So if those two angles are equal, if these two angles are equal, then these two angles would be equal. All right. So if these two angles are equal, then the bottom two would be equal because it's isosceles trapezoid. Let me just show you isosceles trapezoid, and you will see that if you look carefully, I want a good one to show you. I can see the angles. Yeah. There we go. So here it is. For isosceles trapezoid, if these two is 129, if both of these are 129, then both of these must be the same thing. So you understand what I'm saying? So if these two are equal, then the bottom two must be equal. Alright?
Because they parallel?
Say it again.
Is it because they're parallel?
No, it's because we're dealing with isosceles trapezoid. So once we deal in a situation where the top is the same angle, then the bottom must follow naturally. And that's exactly the case that we have right
Okay.
here. Yeah, we have where we know that these two are 135. And how do we know that these two are 135?
Because all the angles all together.
Yeah, because of this formula, right? That each of these red spots supposed to be equal to 135. The interior angles of the trapezium must be equal to, interior angles of this octagon must be equal to 135. So this is 135, and this is 135. Again, both of them are 135 because all of the interior angles of a octagon, a regular octagon, must be what?
Equal.
Must be equal to what? 135. Right? So all these ones in red must be equal to 135. So these are not these are no different. So both of these are 135. Now z is just this portion right now, right? This small little part. And if these top are equal, then the bottom must also be equal. See what I'm saying? And so that would be z as well. Alright, so the top two are equal to 135. So the bottom two must be equal to 135. I mean, the bottom two must be equal to each other. Not equal to 135, but equal to each other. So that's why if this is z, this must also be z. You understand that?
Yes, sir.
Alright. Now, all of them together, angles in a quadrilateral, must add up to what? Angles in a quadrilateral.
360.
360.
360.
So that means that we're gonna have for C. Let's go on for C. This is just gonna be our working for C. We're gonna have Z plus Z plus 135 plus what? 135. Now, some people may be asking where we get this from. That's directly from our little thing we had going on there, where we had this was 135. This is 135. This was Z, and this was Z. And so all of them together must equal to 360 degrees. And so we know Z plus Z is simply 2Z plus 135 plus 135 is what?
280.
What'd you say?
No, 270. My bad.
270?
Yes, sir.
I know say that so confidently, you almost make me doubt myself.
I didn't use, I guessed it. I said it on my head. I didn't use no calculator.
Oh my goodness. We send the 270 over. It's gonna be equal to what? 2Z is equal to what? 360 minus 270. And that's gonna be equal to 2Z equals to 360 minus 270 is what?
110.
190.
What?
Wait.
190?
It's 111. 111. Hold on.
What?
11. I mean 110.
Mercy.
Hold on.
270.
90.
90. Gee.
My fault.
Gee.
Me and my little simple mistakes.
Wow.
It was simple mistakes.
Simple mistakes. What type of simple mistakes for that? Nah, simple mistakes. Like,
I don't know why I say 100.
Nah, let's try to play it off. Simple mistakes.
It is a simple mistake.
Boy, listen to me carefully. You don't want to make simple mistakes in the real world. You notice positive 1,000,000 versus negative 1,000,000?
Oh Lord, yes, I know that.
That's you being in debt or you being a millionaire. Can't make that mistake.
Woo.
Say simple mistake. Mr. Petit, what's the problem with a negative? It's just a little negative. Right? You're a negative in the real world. Okay. That's the difference between you are 100 feet in the air or 100 feet underground. Make a mistake.
Yeah, it feel like.
So what is 90 divided by 2?
45.
45. You say that so fast. You say that like rapid. Like that's waiting for me to. Okay. What do you say? Okay, go. Let's go.
Mr. Butini. You know, hello.
Hello, I'm right now.
Mr. Butini. You know, if you're like negative, like if you're in debt in Dubai, they could let you spend lifetime in prison.
Wow, I didn't know that. Send me an article on it.
Wow.
But you know how much people are in debt in Dubai, but they have to work like slaves to pay it off.
Yeah, but other than that, if they don't do that, that's still lifetime.
They over there a lifetime anyway, but they have to work for it.
Sorry to cut y'all off, but we skip Y.
Okay, yeah. So Z is 45. Y is thank you so much. Y is simply gonna be Y is equal to 135 divided by 2. Alright, so it's gonna be equal to what, 67.5?
Makes sense.
Thank you, Ms. Penniman.
Okay, so
Go ahead.
that's 60.5 because the line cut the 135 angle.
Yeah, it cuts it directly in half.
Okay.
Yeah. Directly, you could be a good student. You can make a good math student. Attention to detail. What's case he's making? He's saying y plus y. I don't know, just reason he gave.
It is in the second.
Yeah, we didn't say y though. We didn't say. Did he say y? Oh, okay. Oh, let me see something. You saying it's gonna work out? Oh, okay. Line of symmetry. Yeah. This line of symmetry. It cuts it directly in half.
Excuse me, Mr. P.
Go ahead.
Can you go to 466, please?
Something else to do. So y is 67.5 and z is what is z was again?
45.
45 degrees. Thank you, Mr. Bethel, for pointing me to that video. I didn't even know he did this question.
I don't know how I know.
Yeah, right. Let me know when I can move on, please.
Yeah, I had to play this nice watching Bgcse, but it ended up going on this.
Okay.
I wonder why my head hurting.
When? Now or?
No, last year sometime when I was taking the Bgcse.
Oh, okay.
I thought this was Bgcse.
Oh.
I wonder why it's so in debt.
Oh.
I say, oh, this Bgcse, I need it.
Oh, wow. Y'all are very efficient, boy.
Now it's the other way around.
Why?
Well, actually, no, because I still need some of the stuff with Bgcse too.
Alright. Alright. Let me know when I can move it.
Can you go back on the working for B?
Mr. Petit, do you think they should hold national exams every 6 months?
Mm-hmm. I think that it should be I think the strategy that they have is good. It was one that works. Otherwise, you know, it wouldn't be taken seriously. Persons would lose. Persons would lose the
I have it.
like persons would lose. Maybe persons would be like, you know, I could take this anytime I want. You know.
But I could make an argument like, should it be taken seriously in the first place?
Should it be taken seriously? Yeah, I think so. I think so. I think so because these are fundamentals. These like basic stuff. So
Exactly. So why should you have to wait like a year? You know?
I understand. I understand that case is perfectly fine, and it's hard really to make a case against that. Except to say that you know, manpower has always been an issue in the Bahamas. And so, man, we barely have enough teachers to you know, be in the classroom in Abaco and judge, you know, use time and effort to mark them because you know, you realize that it does take a lot of work to mark them, coursework and all those stuff. So I think we don't have enough personnel, and I'm not talking about janitors and
So you're saying we don't have the infrastructure for it.
no, we don't have the we don't have the we don't have the we do not have the first the manpower, which includes intelligence. I would say we don't have the intelligence for it. That's how I'd make the case. Like we don't like all our and even if we do, we don't have enough to pay them. Um and and also if we do, they occupy with something else. So you know, it's just more. It's just, and that's why they only do it once a year because our exams are not like the thing about the SATs, you know. It's the reason why the SAT is multiple choice. No, you don't have to pay people to mark them. It's just pay people to prepare them and make them, and then throw them inside the machine, and the machine does the marking, and no coursework is involved, you know. And so it's definitely easier to make that exam um, more on a regular basis as opposed to the, say, Bgcse.
All right, makes sense.
Yeah, I mean that's the thing. When you live in a small island, um, you know, third world country, you know, only so much we could do, honestly. Only so much we can do. Wow, we almost finished paper two. Okay, so let's continue. Okay.
Mr. PT, I don't think like we're that bad of like a third world country, you know.
Um,
I think we should be like a little below average in the second world.
whatever. Why?
Because yeah, because in the Bahamas, I don't really see no like poverty, like poor people go down the streets like how other places is. Like I think
that's so funny.
Lionel, you know where you live?
Wait. Yeah, okay,
Lionel, where do you live?
My logic is bad.
Audience, where you
my
live?
logic is bad then.
Lionel, tell if you don't mind, can you tell the audience where you live?
Nassau in the Bahamas.
No. Where do you live, Lionel?
In the Bahamas.
No. You live in a specific place in the Bahamas.
Nassau, Bahamas.
Lionel live in one gated community, far in the Barcode way. And he talking about there's no poverty.
Yeah, poverty and no poverty.
What's a gated community? What's a gated community?
Yeah, Lida living with a big filter on, man.
Exactly. I have a whole. I tell a new man. I been by the house.
Is this question after?
No, this be going to number one. We heading from the back, moving to the forward. So now I did it wrong. So show you the paper. We did number 6.
Oh, so then.
And then they just going back to here, and we got one down to number 5.
Okay.
Man, I telling you, loan security checked me up. They needed my ID. They needed everything from me before they let me just to see Lionel. They checked me 100 times, digging my pocket, digging my car.
Was a big joking.
They take down your license plate and all
that. They take down my license plate. What? They call inside. His mommy said, okay, yeah, he good, he good.
Like you had there the office of the Prime Minister,
I'm
man.
telling you, man. And then I see Lionel playing outside. Carefree. So, poverty. This.
Yeah, like I say, we
How?
live in a second world.
Exactly.
I say like below second world country.
I know.
Slightly below it.
Well, anyway, let's get.
Is this knock him down minister thing, right?
Yes, it's it. Yeah. All right, so I give it a few moments to do that. All right, so we have I like that you saw that Miss Reckley and didn't immediately go to simplify them, because some people would just immediately go to try simplify them. Why can't we do that in this case?
Because they're not. Go ahead, Miss Bethel. Sorry.
Because 1 kilometer is 1,000 meters.
Not the answer I'm looking for. Why can't we?
Because they're not. Oh, okay. Good answer.
They're not basically the same. They're not measured the same. If you understand what I mean. One is greater than the other.
They're not in the same units. Okay. So because they're not in the same units, one is meters, one is kilometers, we can't just go ahead simplifying them like that. We only could do that when the units are the same. All right. So that's a very important rule for ratios. You only can go about simplify them, all that good stuff, if the units are the same. What time is it anyway? Oh, we have plenty of time. Yeah, tonight going slow for real. So we want to convert. So we could convert meters to kilometers or kilometers to meters. Either way would work. I would recommend changing that kilometers to meters. Anyone can think why? I would change the kilometer side to meters. Why do you think so?
You don't want to deal with
decimal.
Yeah, I don't want to deal with decimals. So if I change this to meters, the decimal will move away because it's gonna be big. It's gonna be a bigger value. And so the acronym that we're gonna use is knock him down, minister, don't commit murder. All right. And so here, obviously the K is for kilometers and the M is for meters. All right. And so we're gonna move how much spaces to the left?
3.
1 as well. 2 and 3. All right. Move three spaces to the left. Sorry, to the right. Sorry, to the right. And so we know that we have to work with 3 zeros in front of the 1. So we're dealing with 1,000. Right. Now we have to figure out, are we dividing or multiplying? We know that if we're moving from a bigger unit to a smaller unit, so open your arms wide and then close it in, bring it together. You see the cross, so you know that you're gonna what? You're moving from a big unit to a small unit.
Multiply.
Aye.
Okay. And in this case, we're gonna multiply by what number?
1,000.
Multiply by 1,000. And so that means that 1.5 kilometers is going to be equal to 1.5 times 1,000 meters. It's going to be equal to, remember when we take the 1.5, we multiply it by 1,000. We move it how much times to the right? 1,
3 times.
3.
2, 3. Very good. 3 times. We have to put in our zeros here. So this 0, that 0. So we have 1,500, right? So that's 1,500 meters. So 1.5 kilometers is equal to 1,500 meters.
I got my answer.
All right, you got your answer, right? So you have
Me
600
too.
meters to 1,500 meters. All right. Oh wow. So it started off as a little something in the throat, and it matured into a whole sneezing thing.
That's a science. That's a science.
A sign of what?
Science. Flu-like symptoms.
COVID, baby.
Or you gotta get the rapid antigen.
Ah, boy. All right, so here are we gonna we divide by we simply cross out the zeros, right? So I'd say move this 0 and that 0 and that 0 and that 0 because they're in the same units now. We could do that. So we
Divide by 3.
yeah, and then we can divide by 3 after that. Then we divide by 3. Divide by 3. So 6 divided by 3 is
2.
2. That's Kennedy, eh? Boy, Kennedy. Kennedy's be firing. 15 divided by 3 is
5.
Very good. So 2 to 5. Right? So this is correct. Yeah. All right, let me know when I can move it. Okay. Oh wow, you know what I haven't done? Taking the attendance. Okay, good. All right, so okay, so let's do number 2. So it says a whole number n. So it's very important to know. Is the whole number. So what do we mean by whole number?
Any number that is.
Any number? You sure any number is a whole number?
1 to infinity.
1 to infinity. Count for me. Let me see.
Can it be negative too, right? And negative could be a whole number.
Oh, a negative could be a whole number. Oh, really?
I'm asking.
Oh, negative could be a whole number.
No, it won't, because it won't exist really and truly.
Alright, so whole numbers begin at 0. Okay, so they begin at 0. So if we considering the set of whole numbers, it would be the set which contains the numbers, and we always begin at 0 for whole numbers. Sorry. Ooh.
Oh, gee.
Sorry. One moment. Alright, sorry about that. Right. So it's gonna be 0, 1.
You good, Mr. Petit?
I hope I good. Lionel Lee and my friend. Lionel Star burst off that. I got you, Lionel.
Yeah, that's my
I didn't
friend.
even laugh.
Ah?
I didn't even laugh.
Yeah, right.
I didn't.
Lionel Star
You can
burst
call it a night, eh? Because you sound a little off.
Call it a what night? What night? No, man, we call it a night. I good. I just had a little sneeze there. This is not COVID.
Okay. I was just wondering if you want to call it a night. That's why.
You quick to call it a night.
Because it's Monday, Thursday, huh?
Cause what?
Because it's Monday, Thursday, huh?
Cause it's what?
Monday, Thursday. I don't know how to say it right.
Exactly. Monday through Thursday, 6 to 9. That's the contract.
Mm-hmm.
Alright, so these are whole numbers. 0 to infinity. Notice that we do not have what numbers we do not have here. Before I say it.
Negative numbers.
I don't have
No.
negative numbers. Very good. I also do not have what?
Decimals.
Decimal numbers.
Decimal numbers. Very good. I also do not have what?
Numbers over 10.
Oh my god. No, the ellipsis means
That's it.
Wow.
the ellipsis means we continue forever. Okay.
I like it, Kennedy. She being literal.
Yeah,
Love
Kennedy.
it.
Yeah, I respect it. I
Yeah,
respect it.
Kennedy, like, all right, since we doing this, let's go. Yeah, but okay, let me
Don't answer.
No, man, we're not laughing at you like that. We just smile at the genuineness of the response. You know.
No shy intended.
Say no shy intended. You sometimes it's so bad. Alright, so all the way up to okay, so all the way up to infinity, right? Once they fall in this pattern, they are whole numbers. Right? So whole numbers is any number that fall in the sequence of these in the sequence of numbers that we have listed in. Alright, so that's a whole number. So now they say that we start off with a whole number. And it's important to know what numbers, and you know what, when we start off next year, for those who are gonna be with us next year, we need to really start off, I believe, we gotta start off with at least somewhere in the beginning with differentiating the different types of numbers, man. Like whole numbers, integers, you know, rationals, irrationals, imaginary, you know.
Sound like set theory.
That's a part of it. You know, you would wanna know what. I think the first thing to start off with any math program is sets. Believe it or not. Because without sets you can't do nothing. But
Speaking of sets, did you ever watch that video I sent you or no?
That you on read.
I didn't have him on read. No, I said I haven't watched it yet. All right, so anyway, so W, yeah, that's the whole number. So a whole number is rounded off to one significant figure to give 400. Write down the smallest whole number n could be. Write down the largest whole number n could be. Okay, thank you. All right, so let's think about it. So it's rounded off to one significant figure to give 400. Okay, so there's multiple ones that could do that. So let's say, for example, we have 3, 9, 9, right? Rounded off to one significant figure. If it's the one significant figure, we know that the number we consider is the 9 at the bottom. All right, so this will work. If we round it off, it'll give us what? 400. That could work. Give me another one that could work.
398.
398. Very good, Kennedy. 398 could work. Because 398.
119.
Wait, one moment. 398, if we round it off, we know that 9 is bigger than 5, so it would be 400 if we round it off. Give me another one that could work. Another one that could work.
375, because, 375, you know.
Very good. Kennedy knocking the date. 375 could work. Because if we know that 7 is bigger than 5, so it's going to be 400. Anyone else? Come on. What else could work?
How 375 could be rounded to 400?
Because, okay, look. If we know that this is what? Bigger than 5.
You round it to the nearest what?
We round it to the nearest, we round it to the first significant figure. And if you want to cut it a different way, we round it to the nearest hundreds. Okay.
Oh, they rounded to the nearest hundreds.
Yeah.
Okay.
All right. So plus what? 400. Someone is saying, you saying someone? One matters. You saying something?
I knew.
You saying something? He's giving me a number that could work.
Oh, you say 355.
355 could work. 355.
What about 401?
401 could work. Yes, sir. So 355 would be 400. I like this one. 401 could work because when you look at 0, 0 is less than 5, so it's gonna remain as 400. So we know what could work. The question is, give me the smallest number that could work. Like if you go smaller than this, it ain't gonna work no more.
350.
350. Let's see. 350. That's correct. Because below this is 349. Ain't that happening? Yeah, 350 is the lowest.
What about 450?
Now the largest n could be the largest one that could work.
449.
449. Yes, 449. If we go any higher on this, ain't it happening?
Oh, so why are you going?
I confused. It is 400
on this one, and then 350 on the top one.
Because they asked for the smallest here.
And is it 400?
Yeah. Okay. Round this to the nearest. Round this to the nearest hundreds. So round this to one significant figure. It'll be this. If we look over here, the number is 4, so it'll be 400.
Oh, I never thought. Okay, all right.
Yeah, it would be 400.
I don't get it.
You don't get it?
I don't get how you could put one as 49, one as 50.
What you mean? All right.
I don't know how you could do it.
Okay, what you want this to be then? What you want B to be? The largest whole number, that N50. What you want it to be?
Wouldn't that be 450?
What, this?
Yeah.
Okay, let's assume that it's 450. All right? So we assuming that it's 450. This is gonna be a proof by contradiction. So if this is 450, right? Round this to the nearest 100.
Wouldn't that be 400? No.
No, sir.
So how would you round the top one then?
Okay. Let's look at this.
That's what I feel contradicted about.
Okay, let's look at this, right? So 450, we know 5 is, if it's 5 or greater, we add 1, right? So if we add 1, it's going to be equal to 500. Right? But here, if we go here and we look at 5 and we add 1, it's going to give us what? 400. You understand that, Mr. Bethel?
So with the 499, wouldn't that 9 make the 4 or 5, and that'd be 500?
You mean this?
Yeah.
Okay, with this one, you look at the 4. This 4 is not big enough to make this one 5.
But wouldn't the 9 make that 5?
No, you can't look at the 9. You have to look at the number. No, you can't look at the 9. You have to look at the number right before, right after. You know how to round? Like, you know how to do rounding?
By intuition.
Oh my goodness. You need to learn how to round.
I know how to round. That's not like this.
No, I don't know what type of.
You know I ain't being in grade 3, right?
What you mean you ain't being in grade 3? You need to.
I ain't being in grade 3. I ain't being in grade 1, and I ain't being in grade 3. They sent me to grade 2, and then they sent me to grade 4.
Wow. Okay. Oh wow. We need to watch a YouTube video on round.
Oh, they skipped you. Oh, you got it good. No.
I know why they try to push me.
How we get it good?
Yeah, because he's smart, Mr. BC.
I mean, I break my legs. What you want me to do?
Because he's smart.
And then they break the 2 of my legs.
Okay, let me show you
like,
how to round.
What you want me to What do you want me to do?
Okay, quick, thing on rounding. Oh my. Okay. All right, so.
Consequently, that's when you're supposed to learn how to write too.
Oh my goodness. All right, so round this to the nearest 100. So if we round this to the nearest 100, the first thing we do is
that'll be 300, right?
Wait, we circle this number. That's the 100th place. Then we look at the immediate right. That's the only number we can learn about, the immediate right. Is it less than 5?
Yes, sir.
It is less than 5. So
it is less than 5.
Less than 5, we round down. So if it's less than 5, we round down. If it's 5 or greater, we round up. Okay. So we can't add 1 to this, so it just be, we keep the 3, and everything else becomes 0. Okay, so 300. Okay, next up we have the number that we consider 350. All right, so 350. Round to the nearest 100. We circle 3. Underline 5. Is 5 or greater?
Yes.
Yes. So we add 1 because we're rounding up now. So this becomes what? 3 plus 1, which is what?
4.
Everything else becomes 0. So that's why it's 400. Okay. Now let's consider 449. So 4 4.
I get it, Miss Petite.
Okay, you get it.
But I just didn't know you only use the number before after the first one.
Oh yeah.
I was using like the number after that too.
No. We don't use that as well. Just this number. All right. Okay, so the answer is 350 for the first one and 449 for the second one.
BJ, keep this on for a little bit. Because my mommy called me to do something and I just came back.
No problem. Remember, 450 is not a part of the answer. The only answer for this one is 350 and 449. Remember that, please. Remember that. Yeah. Guess who messaged me?
Aston.
No, not Aston.
Cooper.
Oh wow.
Yeah. Cooper says she having a good time. She having a blast.
Mashing up them hot cross buns, man.
Boy. I'm just kidding. She just said she could need the recording for the night.
Well, that was disappointing.
Yeah. I can need the recording for the night. Mr. Petite, I can need the recording for tonight. Alright. Okay, good. Okay, so let's continue. So 350 and 449. Now next up we need Alright. This would be a fun one. I like doing stuff like these. Alright. Alright. So attempt that for me, please.
Jeez.
Oh wait. Lionel, I have a special belt for you.
Oh, I knew Mr. BT is disciplined people.
I have a special belt.
Turn up his behind. Tell him.
You need a good one.
Excuse me, Mr. Petit. This where we draw the integer line, right?
No, you don't draw the integer lines in this one. They just want the statements.
Okay.
Alright, so let's try it. Are we ready?
No, sir.
Okay.
Yes, sir.
Okay. Alright, so W is more than 37. How do we do that? What do we do?
I mean, where we put the greater sign and then we put 37
W.
W, help me out. W.
W, open pot mind mode, 37.
Yeah.
Alright. X is smaller than twice Y.
X And then you're gonna open the mouth the opposite way.
Okay. Very good.
To Y.
Very good.
I did that too.
Very good. Ah, that's a good one. 7 Z is at least 23.
It's equal. It's equal.
You're going to put Z, the mouth with the underline, a line underneath 20.
Wow. Very good, Nance. Very good. Who's your teacher? I don't know. Gee. Smart, baby. Wow. Very good.
I don't even remember. I remember doing it. You see the C part with the thing on the underline. I remember doing that.
You remember doing that, eh?
That's what you get about yes.
My old junior school, I do this.
All we do in this class was that for the first 5 weeks.
My egg.
I was in here for the first 5 weeks.
Yeah, right. You mean how?
Yeah, please.
Very good. I'm glad that you got that. That's a very important one.
I don't know how to get that, Mr. Petit.
You got it too, eh?
Yeah, we've been doing so much.
I know what I'm saying. We do it like even before you left on your sabbatical.
I got it as well.
I might call it a little excursion, but
like that's the only one like I remembered from when we start class. Like I remember that.
Don't flex.
Yeah, that's the only one we really grind.
Yeah, we really inequalities. We really weeks of that. Weeks upon weeks upon weeks. Days upon days. Draw the inequality. Do it on a line.
Because I was already drawing my line and the little circle with the
Yeah, we do that. We really drill down on it. Anything we drill that. All right, so let's move on. I think that's the last question. 7:59. What I will do.
That's a good place to leave off.
Yeah, it's a good place to leave off. So we would begin with number 4. Do number 4 for homework, please. Do number 4 for homework. Oh, this is gonna be a good place to start off. Do number 4 for HW. Wait, y'all have a long Easter break, right? Wait, no, my bad.
Some people have 2 weeks.
Hey.
No. I just remember classes resume on Monday. At 6 p.m.
That Monday, holiday Monday?
What you mean holiday? What you mean by holiday? What is holiday? What does that mean?
No, I'm actually, is it that holiday Monday?
What is holiday?
Yeah.
I mean,
it's a day for break, Mr. PT.
I mean 18th. The 18th Monday. Yes, that one.
All right.
Yeah. So we don't have to come to class?
Class, yes. Have to come to class.
Mr. PT, you don't believe in breaks, eh?
What do you mean with breaks? You all have
I can imagine
a couple weeks. What do you mean breaks?
Mr. PT.
I can imagine as a joke.
Seems like you're trying to catch your break when you're in the crib, man. What's going on?
I could imagine Mr. BT as a gym teacher or PE teacher. Imagine how Mr. BT would carry on. No breaks.
Anyway, have a wonderful night, everyone. For those who have to leave, for those of us who have to stay for social and arcade, you are welcome to stay.
Yeah,
all right, good night.
All right, good night.
Good night. Have a wonderful one.
Good night. See y'all Tuesday.
What?
Mr. Bethel, he ain't loyal, boy. Oh, boy. See you on Monday, Mr. Bethel.
That's my sacred day.
It's a sacred day. Holy Monday.
Yeah, you know, sometimes you gotta respect people's religion. So,
Oh boy, cause today is Holy Thursday. So why are you still there?
no, I don't believe in that part of the.
You don't believe in that part?
No.
All right. All right. Let's continue.
This class empty. Jeez.
Okay. Okay, social. Where we left off. It's been a while since we did social, you know, because we missed last week.
Yeah.
Yeah, it's been a while.
And they didn't want me to do it on Monday for some silly reason.
We didn't do it on Monday. All right. Okay, let's go. Now, so we got a lot of backtracking to do. What were we on? We was heading somewhere. We was going somewhere, going places with our thoughts. We was talking about, anyone can remember? I know it was a while back, but anyone could remember what was the
That was like 2 weeks ago.
Yeah. The last thing is on in social. Kennedy, where's Kennedy? My good Kennedy. What's the last thing is on? Remember, Kennedy? Oh, she going to? Sure, y'all. Okay, so we was talking about the beginnings of the European exploration, and we are good ways into that. And we was asking the question. We already asked the question, but motivated them. We already asked that question. Why sea Europe by sea? So we know their motivations. We know why they went. You know, they went to they went because they was motivated by fame. They was motivated by money. They was motivated by showing people that they are true and good explorers. They went also because of a love of adventure. They also went because there was external factors like, you know, the king and queens wanting to expand their domain and territory. They know that they can expand their domain and territory.
But let's be real.
Uh-huh.
They gone because it was a business investment.
Yeah, that's exactly the case I'm making. And so they know that they cannot expand their territory in Europe, because if they do it in Europe, they have to go to war to do it. And so they say, you know what, let's go and try find other islands, other territories. And you know, the more territory you have, if you're the first to claim it, it's yours, and you get to, you know, get the fortunes of whatever that land possesses. They was also motivated by the fact that they could turn these peoples into Christians, and that would please the Pope. And so that was their motivations, at least according to the text that we use it. That was their motivations that they had. And so
they wanted a faster trade route.
Yes, and they wanted a faster trade route to get to the east. And so, like we said, we talked about motivations, you know, rivalry between different countries, increasing wealth of the rulers, you know, to prove themselves professional navigators. They wanted to get rich through trade, to convert people to Christianity, and they wanted an adventure and to become famous. And so that's what we was talking about. And then so we know their motivations, and then now we also was talking about, okay, what made this all possible, right? So what really helped to make it possible? Yeah, they have these motivations, but what made it possible? And this is what we was talking about probably the last time
the money.
Yeah. That made it possible, but there's also something very significant, because they could have the money, but if they don't have this, it wouldn't work. And
the navigation
what?
Map?
The map is a part of it.
The compass?
The compass, yeah. But what really was a great part of it was actually the ship, believe it or not.
True.
Yeah, the ship. And this type of ship was recently invented for the sake of doing these long voyages. If they didn't have that type of ship, then they could not do it. And also the other navigational tools that was made to facilitate long travel helped to make it all possible. Now what helped to make all those ideas possible and all those inventions possible was the Renaissance, and that's what we basically is talking about. That's what we introduced last time, talking about the Renaissance and the impact of the Renaissance, and we said that the Renaissance is basically a rediscovery, like we said. All right, Renaissance is a rediscovery, right? And it basically means rebirth, right? The rebirth of knowledge. The reason why it's a rebirth is because the Greeks and the Romans already, did a lot in terms of learning and inventions and ideas. But during the Renaissance, because the power of the church was becoming less and less, creativity spawned, and art and sciences and intelligence, found its original roots, and then from those things that they learned from the Greeks and Romans, they was able to create original work. And so, but during the Middle Ages, things were stagnant. Knowledge was stagnant, and inventions were stagnant, and it wasn't moving. But after the Renaissance, of course, like they say, because the church was powerful and stuff like that, and they would stop certain inventions. But during the Renaissance, the church power was less and less, and so even inventions and ideas and going back to being free and able to do what you want to do and study what you want to study was there back again. And so a lot of new inventions happened, including the things and the inventions that facilitated the navigation. All right, and so that's what we're going to talk about right now. All right. One moment. So we're gonna talk about, today is the Monday, Tuesday, Wednesday, Thursday. Thursday, the what? The 14th of April. Alright, so please take down these notes for me and bring them and send them to me via WhatsApp. Oh wow, I just go all the way down there. Okay. Alright. Alright. Alright, Thursday, the 14th of April. Oh, today's the 14th of April! Oh! Oh my goodness. Today's an important day. Very important day. Okay. So social studies.
Miss your anniversary?
Not anniversary. Family birthday. Someone in my family. Very close.
Oh, you're not important then.
No, very important. Very important. This person really.
Oh, yeah. And you gotta leave early. Yeah. Celebrate your family.
All right. So mass instruments and ships. So before the 15th century, European sailors, there's just the notes to take down. European sailors could not travel far from land. Why not? Why? Why they can travel far from land?
So the Pope lies.
One of the reasons was that navigation methods
Oh.
were primitive. All right. And the maps, you know me say primitive, right? And the maps available. Primitive means like simple, right? So, and the maps available did not show more than Europe. The Mediterranean, and part of the African coast. And you know, many things we take for granted now, you know, this knowledge that we have in all areas. You know, it's only a few things where we're ignorant on, you know, for practical purposes. And sometimes we take it for granted. You know, we see the whole map of the world and we know every continent and we see every sea and every little peninsula. But it wasn't always like that. You know what I mean? Um, you can imagine only having a half of a map or a portion of a map, you know, and of course you can't navigate if you don't have enough of the map. All right. So between, so what did they do? What they did was they between Asia, so between Asia and Europe, a Western Ocean was always drawn. Dotted with imaginary lines. Sorry, dotted with imaginary lines. Right? It's supposed to be Western. Dotted with imaginary lines. Sorry, imaginary islands rather. But no continents. And they didn't know that, you know, these continents exist. Right? The supposed vast size of the ocean was what prevented explorers from tackling a new western route to the east. So what was it saying? This is saying that, hey, I mean, even when you go by the beach, right? And you look at the sea, and you look at from end to end, you be like, wow, this thing is so vast. Like, like you look and you be like, wow, like, will this ever end? Like, imagine if you didn't know but the map, right? Imagine if you didn't know but the map, and you didn't know where you're going, and you only had half of a map, only had a portion of a map, or the maps that you have is not developed yet to show you exactly that there is other lands, you know, and if you go far enough, you will find land. Imagine how you would be. Like, would you even think to go in that direction? You'd be like, wow, like, why even go in that direction? Like, you know, it's so mysterious, right? It's so mysterious, right? Why would I even go in that direction? You understand what I'm saying? Y'all understand? Y'all get what I'm saying? Hello? My people there? What? Rejoin. What? Okay, so we gotta return. Oh wow. Wow. Hello? Hello? Hello?
Hello.
Yeah, sorry about that. Oh boy. So where did I left y'all at? I thought I was talking all hour. Oh my goodness. And then I asked the question and nobody answered. I was like, what? Okay. Where did I left y'all at?
With the maps. How is it primitive?
What? From then? From then, Miss Kennedy?
Yes, sir.
Okay. Okay, so what I was saying is that the math is so simple that it only showed so much, right? And I was trying to say that imagine that you only had, you know, a limited amount of map, right? What I mean is that you only had a map that only showed you a limited amount of, the world. And so, you're a sailor and, you want to adventure, but all you look at and you see is just the ocean. And so my question is, would you go and still adventure? Would you go?
Why not? Yeah.
You would go? Anyone else? Remember, your map only show you so much. And you don't know what's out there. So it's mysterious, right? So you don't know. Sorry. You don't know if you're gonna find land, right? And so for these explorers, they thought that the ocean was so vast. Excuse me. Sorry. They thought that the ocean was so vast and so big, right? That, they're like, ain't nothing else is out there. Ain't nothing else is out there. Can't be no more land because the ocean is so vast and it's so big and all we'll be doing is just sailing on ocean forever and ever. We'll never find land. That's what they thought. So, sorry, someone asked me to join. Okay. So, like we said here, the supposed vast size of the ocean was what prevented explorers from tackling a new western route to the east. Okay, you understand that?
Yes, sir.
So they're saying that they thought that the, the ocean was so big that, hey, even if we go with our boats out there, we ain't finding no more land. Like, this is all the land there is. Okay? And so it prevented them from going west. Okay? But by the late 15th century, right? Excuse me. Certain navigational. Sorry. So Mr. Floyd left. Mr. Bethel, he left.
Yes, sir. You left.
Okay. Anyway, by the late 15th century, certain navigational. Sorry, navigation. Certain navigational instruments, and by navigational instruments, they just mean instruments that we use at sea, right, on the waters, had been invented that vastly improved the situation. And that's good. Okay. The compass. So one of the things that was invented was the compass. The compass had been used in Europe since the 12th century. But it was now mounted on ships in a structure called a gimbal, all right, to allow it to move freely. So they always used the compass since the 12th century. Now we're in the 15th century, so it's quite a bit of time since they have been using the compass. But now they put in the compass in a structure called a gimbal, and it allow it to move freely. Let me show you what I mean by a gimbal. And obviously this would help with knowing where to go, right? Right. Okay, so no gimbal on ships. Okay, so this is a good one, right? You see that it would allow it to move. It would allow the compass to move. It's a nautical gimbal, right? So it allows the compass to move as the compass wants to move. Okay, there's another one, right? All right. So this is a good one too. As you can see, it's on the gimbal, and the compass is allowed to move how it need to move, so as to give you the right direction. Okay, so it needs to move freely. Okay, move freely and always point. Where would the compass always point? In which direction does the compass always point? Anyone? Are they there?
Can you repeat the question, please?
Yeah, in which direction does the compass always point?
North.
North, right? So it allowed to move freely and always point north But something is influencing it though. Always point north under the influence of what? Of the Earth's
Gravity.
not gravity, start with M though. M-A.
Magnetic field.
Yeah, magnetism. Okay. So the compass helped to improve the situation when they put the compass on the ship and put it on the gimbal, and it was allowed to move freely. So the compass was a good help when it comes to helping the sailors navigate, in a way that they couldn't navigate before. Remember we said that the European sailors before they couldn't travel very far from the land because they didn't have the right instruments. And one of the instruments that helped them was when they put the compass on the ship, and it helps them with direction. The next one is what we call the quadrant. So new instruments. So the compass was an old instrument, right? They saw that before. They just put it on the ship. Now this one, a new instrument, right? New instruments like the quadrant, right? New instrument like the quadrant, or we say astrobal. It's also called astrolabe, not label. Astrolabe with the E. Okay, astrolabe. So new instruments like the quadrant or astrolabe check the position of the ship relative to the equator by fixing the sun by day, and then in the night, guess what they would use? Or the North Star by night. Or above the horizon. Alright. And I mean, it's gonna be the last one that we talked about. So we talked about the compass, the quadrant. Anyone know how the quadrant look? The quadrant.
It look like a ruler, in my opinion, like a circular ruler.
No, not really. The quadrant. Not like a ruler, Like, look like a piece of a circle. So quadrant. So nautical quadrant. We need to see something like this. It's a quadrant. Okay. These are quadrants. Alright. It's a good one. This is someone using it. Right? It's a quadrant right now. Pretty decent, eh?
Nice for the 15th century.
Yeah. Yeah. You can imagine how heavy this thing was, though. Right?
I want to imagine how heavy that is now.
Yeah. Okay, so now function. They like asking function of these things in your multiple choice. So it allows the user to determine his or her latitude by measuring the altitude of the heavenly body. So it tells you where you are by determining how high a star or the sun is, right? Okay. All right. Okay, nice. Okay, so it's a quadrant. So we talked about the compass direction, quadrant to check the position of the ship. All right. So the compass is used to check the direction. The quadrant is used to tell us the position of the ship. And then we have the almanac, right? So an astronomer's almanac was used to check up on the angles involved and to complete the calculation of latitude. So the quadrant and the astronomer's almanac was used hand in hand to determine the position of the ship. All right. And I'm going to show you the astronomer's almanac. All right. So it's just basically a book whereby you could use as a reference to tell you when you're using this quadrant, it's gonna help you to check on the angles to basically complete the calculation. So it's basically a book that they use along with using the quadrant to help them with their calculations of where exactly the ship is. All right. And so this is by hand, so you're not the digital thing like we have now, you know. And so that's something. All right, so we're gonna end it out. The next time we come, we're gonna finish talk about the other inventions like the hourglass, the log, the lead, and the ship itself. All right. Started on social studies. Let me know if I can move this if y'all have it already.
Yes, sir.
Okay.
Yes, sir, I got it.
Okay. That's good. Make sure please send me the notes of it so I can see that you're following along. In our last few moments together, we're gonna look at religious. And so the last subject that we did, religious studies, was Jesus calling Levi. Right? That was the last topic that we. No. Last topic we did was the 12 disciples, right? No. Yeah, Jesus calls Levi. That's the last topic. He's the first person Jesus called a disciple, and his other name was, what is he also known as?
Matthew.
You saw that in the screen just now.
Oh.
No? Okay, good. Very good. So he's also known as Matthew. What was his trade? What did he do for a living?
He's a tax collector.
Yeah, he was a tax collector. Now, was tax collectors liked a lot?
Oh, they was hated.
They were hated. Very good. Right? The people hated them. I mean, who likes to be taxed, right? You know, who likes to be taxed? Right? No one really likes to be taxed. So you know, and plus the tax collectors were seen as, they were seen as traitors, man. How could y'all do this? How could you do this? And so the tax collectors, people didn't like them really, and but Jesus saw inside this tax collector someone who would follow him, and so he called Levi. That's the last thing that we did. Today we're going to talk about Jesus is rejected at Nazareth. Now, what's so important about Nazareth, if anyone knows? What's so important about
Supposed to be his birth town.
It's not birth town. Nazareth was not the place where Jesus was born. Anyone else? What's so significant about Nazareth? No one? Oh, we really need Cooper back. We really do. And they're so quiet. Nazareth. What's so significant about Nazareth?
His parents were there.
His parents is there, but that's where he grew up. Okay, so Nazareth was the place where he grew up. And it's interesting that he got rejected at his own hometown, right? Um, and so that's something, right? It goes to show that. So he got rejected in his own hometown, but other places where they didn't know him like that, they received him gladly, right? What's the lesson in that?
It was something about the scripture saying that everyone can love you, everyone else but your own town.
Yes, yes, yes. So a prophet is respected everywhere else except in their own hometown and by their own relatives and family, right? And that's so true. Like, you know, um, you inside your own house or inside your own, let's say for example in your school or say for example in your class, right? Um, and you do extremely well, no one tell you nothing. The moment you go outside to see another, another school or a different place, and they say, "What? You mean you did this? You did that? Wow, that's so amazing! How did you do that? Wow, that's so cool!" Right? They respect you way more than the people who are around you. Anyone know what I'm talking about?
Agree, especially in the Bahamas.
Yeah, right. So that's what they're talking about. And so Jesus experienced the same thing. Um, and so that's what we're gonna talk about. And then we can leave. So let's write down these notes. Um, so Jesus had finished healing a demon-possessed man. And bringing Jairus' daughter back to life. And so he decided to stop home, which was Nazareth. That's where he grew up. That's why they say, can any good thing come out of Nazareth with his disciples?
No. Oh yeah, yeah.
Now, when the Sabbath came, Jesus began to teach in the synagogue. While there, he read from the book of Isaiah. He told the people that he was the one whom the prophet was speaking about. So Jesus is reading inside. He's reading inside. He went inside the synagogue on the Sabbath, and he started reading from the book of Isaiah, a prophecy concerning the Messiah. And he tells the people, hey, listen, you already have to wait no further. I am the one whom this prophecy is talking about. And obviously, you know, they like, you? Who, you? You. You know who you is? You is Joseph's son. I mean, so you is Mary, little boy from, you know, we know you, we watch you grow up, you know? And so, what you mean you is the whole Messiah? How you get the Messiah? Right? And so that's what got them angry. Because he told them that he is the one whom the prophet was in the passage was talking about. In the reading. Now the crowd was shocked. Right? So they were shocked to hear how powerful the message was. The message was. They were further surprised at the miracles Jesus performed. The people wanted to know several things. Number one, where did he get his teaching from? Where he got his teaching, where he got his wisdom or understanding of the scriptures. How he was able to perform miracles. And wasn't he just a carpenter? The son of Mary. There's a lot of questions, right?
I know.
Yeah. And we're not his family, local people living right in that town. Sorry. So these questions show that the people thought Jesus was no different from them. They did not respect, they did not think that he deserved their respect and attention. Now, because the people knew Jesus from birth, they refused to accept his message and his works. Instead, they rejected him and did not listen to what he had to say. So how did Jesus respond to all this? Jesus said to them, prophets are respected everywhere except in their own hometown. And by their relatives and family. Okay. Now, because of their lack of faith, Jesus was only able to lay his hands on them, on a few sick people, and heal them. Okay? Alright, so that brings us to the end of that. Alright. Any questions for me about it?
No, sir.
Okay. Alright. Let me know when I get more of it.
You can move it.
Alright. Okay. Okay, like I said, that brings us to the end of the study. I would want to say to you all, have a wonderful weekend. Have a wonderful holiday. Stay safe, and I'll see you on Monday, God's Spare Life at 6 p.m. All right?
That's all.
Yes. All right. Good night. Have a good one.
Good night.